Okay, this video is going to be myself solving 3 of your homework questions in lesson 5. So I'll do questions 13, 14, and 15. I like doing these 3 questions because with question 14 and 15, I've seen students solve those 2 questions in particular a variety of different ways. And so I'll show you a couple of different methods. For this first one though, you're just evaluating this expression. So we're going to be adding 2 logs together. How they want you to do this for this particular lesson is by doing change of base. So this log right here, you would evaluate it as log of 8 over log of root 2. So doing change of base to convert it to base 10. If you typed in on your calculator log of 8 divided by log of root 2, it would give you 6. And then to that, we're going to have 2 times the log base 9 of 3. So again, I would take the log base 9 of 3 and I would evaluate that using the change of base. So that would be the log of 3 divided by the log of 9. You would type that in on your calculator, and the log of 3 divided by the log of 9 is 1/2. And then to that, you were going to multiply it by 2. So what we would get is this log was 6 plus 2 times this evaluation would give you 1/2. That would be 6 plus, this would be 2 over 2, which is 1, and your answer would be 7. And then it says to the nearest tenth, so you would write down 7.0. Okay, question number 14. I consider this a standard of excellence question, and like I said, there's a couple of different ways that you could actually solve this. So I'm going to show you a different method than the workbook solutions, just so that you could see a variety of ways. So I'm going to rewrite this, and it's the log base 7 of x is equal to the log base 4 of 60. So what your book does is for each of these logs, it does change of base. So this, it would say log of x divided by log of 7, log of 60 divided by log of 4, and then it's going to manipulate to get the log of x by itself, takes it out of log form into exponential. It's a lot of work. I'm going to show you an alternate method. Sometimes students will look at this and they will say, okay, I've got 2 logs, but I could go out of log form by saying 7 to that power is equal to x. So 7 to the power of the log base 4 of 60, and that is all equal to x. If you're able to evaluate this, you've evaluated what x is. So I'm just going to write this as change of base. So x is equal to 7 to the power of, so this would be the log of 60 over the log of 4. Now, how I recommend doing this on your calculator is let's evaluate what the log of 60 divided by the log of 4 is. And then with that number stored in my calculator, I'm going to then type in 7 to that power. So if you take out your calculators, I think I should have entered this for us. So here's the log of 60 divided by log of 4, which is 2.953. So what we're getting is x is equal to 7 to the power of 2.953. And if I evaluate that, we would get x is equal to 7 to the power of, and this answer right here. There's my answer. And it says, what is the value of x to the nearest whole number? The answer would be 313. Okay, an alternate way that you could do this. So I'll show you another method. I think that this was sort of the easiest method, but I'm going to show you a different method that you could get this answer. And again, it is very similar to what's done in the workbook, but it's just a second method. So let's say you didn't see that we could go out of log form into exponential form. A lot of you will be doing change of base. So this is mostly how your workbook does it, but it is the log of x divided by the log of 7. This is equal to, if I do change of base over here, the log of 60 divided by the log of 4. Now we enter this onto our calculator. So I'm going to just rewrite this, log of 7, or sorry, log of x over the log of 7 is equal to, remember that this answer was 2.953. We need to essentially isolate the log of x. So in order to get the log of x by itself, I'm going to multiply both sides by the log of 7. And then what I will have is I will have the log of x is equal to, so this answer here times the log of 7, and that gives me 2.495. So the log of x is equal to 2.495. In order to get out of log form to exponential form, you have to realize that this is a common log, which is base 10. So 10 to that power is equal, the argument becomes the answer. So once I type in 10 to that power, I have what x is, and it should be the exact same answer of 313. So we'll just verify that. So 10 to the power of that, there's our 313. So two different methods that you could use to solve this. All right, let's look at class example, or sorry, the last homework question, which is 15. So I'm just going to move this out of the way. Okay, so here's question 15. Again, I'm going to show you two methods in order to do this. So what they've given us is they've given me the log base x of 27 is equal to the log base 12 of 3. So again, I could do what I did in the first class example. I could say x to that power is equal to 27. So x to the power of log base 12 of 3 is equal to 27. X to the power of, so now I need to figure out what this is. So to do that, I'm going to do change of base. So that would be log of 3 divided by log of 12. Is equal to 27. And then I'm going to do x to the power of, I need to figure out what the log of 3 divided by the log of 12 is. So my calculator, and I would get that answer there. So this is one of the methods that I've seen students solve this. So x to the power of, I should have to get that answer, 0.442 is equal to 27. If I said, well, what could you raise? We need to get x by itself, right? We need to get x to the power of 1, and then we'll have what x is equal to. So if I said, well, what could you raise this to the power of that would cancel this? We know that if I reciprocate this, so this is 0.442 over 1, if I raise this to the power of 1 over 0.442, what I do to one side, I have to do the other side. So I raise 27 to the power of 1 over 0.442. And then this would give me 0.442 over 0.442, which would be x to the power of 1, which is what I want. And then I'd have to type in 27, the power of and I would need to type in 1 divided by the answer that I had. So on my calculator, 27 to the power of, 1 divided by this. And there is your answer of x is equal to 1728. So this is one method that you could do it, 1728. Okay, how your book does this is slightly different. They're going to do just change of base for everything. So they will do the log of 27 all over the log of x is equal to the log of 3 divided by the log of 12. I know that this answer here is, remember when we typed that in, log of 3 divided by log of 12, it was 0.442. So what I would have, so that was 0.442. So I would have the log of 27 over the log of x. From here, we really want the log of x by itself. So you'd be doing cross multiplying, but remember that the trick that you could do is you could swap these. That's basically cross multiplying and dividing. But the log of 27 divided by the log of x would be, the log of 27 divided by 0.442. That would be equal to the log of x. I need to figure out what this is on my calculator. So the log of 27. So the log of 27 divided by that 0.442 would give you this number here. So 3.237. Is equal to the log of x. And again, we're in log form. We need to get out of log form by going into exponential form in order to solve for x. You need to realize that this is a common log, which is a base of 10. So if you raise 10 to that power, which was 3.237, that will give you, the argument becomes your answer. So 10 raised to the power of 3.237 will give you the exact same answer of 1728. So just different methods that you could use to solve, and you would get to the exact same answer.